understood how to find the derivation for, I think I have started recording. Okay, how to find the derivation for getting RA of n and V of f. Okay, for various formatting technique. So I have summarized that here in this table. You can see this table. This table will give you the summary of whatever derivations we have done for the previous video lecture and in the classroom session. So you can see V of f for unipolar, polar and bipolar are one and the same. And for RA of n for polar and Manchester are the same. So this derivation we completed in the previous video lecture. This is being summarized here. Now we are ready to write the expression, find the expression for the power spectra. So using this table we can do that. So let us do one by one. So let me first take polar format and Manchester format, bipolar format. We will go by this order. That is, first let us complete polar, Manchester, quaternary, then complete bipolar and then unipolar. This is why, because you can see in polar format and Manchester format and quaternary format, you have RA of n is some value, finite value only for n is equal to 0 and 0 otherwise. So in these three format you can see. So therefore it is more than enough. We are just concentrating for n equal to 0. So the derivation is easy. Okay, so let us complete for in this order, then we will go to the other two things. Okay, so generally power spectra equation, what we have seen is nothing but Sx of f equal to V of f modulus the whole square by t summation n equal to minus infinity to plus infinity RA of n e power minus j 2 pi n f capital T. So this is the general equation which I have discussed in the class also. So now when we are concentrating on the polar formatting, power spectra calculation for polar formatting. So polar formatting, you can refer this table. In this table, polar NRZ format, what is VF? VF is TB, sync of FTB. And what is RA of n? RA of n is existing only for n is equal to 0. And when n is not equal to 0, it is 0. So within this summation, you are having n takes the value from minus infinity to plus infinity, you have to submit. But for polar formatting, only n equal to 0, you are having some value for RA of n. When n is not equal to 0, RA of n is 0. So having this one, we can just take only RA of 0. We can neglect all the other factor. So for polar formatting, V of f is TB, sync of FTB, and RA of n is a square, n equal to 0, 0 otherwise. So you're going to concentrate only on one n equal to 0. All the other summation will be 0 only. So putting these two together here, and for capital T is nothing but TB, because only one bit duration. Okay, capital T is TB for polar formatting. So you putting everything together, you have Sx of f is nothing but TB square, sync square of FTB, that is V of f modulus the whole square, divided by T equal to TB, right? So divided by TB into multiplied by, you are having summation for all ranges of n, but we are going to substitute only for n equal to 0. So put n equal to 0, e power 0 becomes 1. So RA of 0 is a square. So this will get cancelled out. So therefore Sx of f is nothing but a square TB sync square of FTB. This is the power spectra in polar formatting. Okay. So next, the power spectra for Manchester formatting. So for Manchester format, again you can write T is nothing but TB, V of f is nothing but JTB, sync of FTB into sine of pi FTB This is for Manchester formatting, J sign, okay. And RA of n equal to a square when n equal to 0 and 0 when n is not equal to 0. So here again you can understand only for n equal to 0 you are having value, when n is not equal to 0 you have 0. So general equation for S of f is modulus of V of f whole square by t summation RA of n e power minus j 2 pi n f t n equal to minus into plus. So now substituting for everything, you substitute t equal to tb here, and v of f is j. As we are having modulus, this j will disappear, so this becomes only the positive component we will take, and here RA of n equal to 0 only we will take. So accordingly, S of f, Sx of f is nothing but in the numerator tb square, sec square of ftb, sine square of pi ftb, divided by in the denominator you have t equal to tb only, multiplied by this entire thing, multiplied by the summation factor, only RA of n equal to 0 you have, which is a square. So finally, Sx of f is nothing but this tb and this 1 times of tb will get cancelled. So a square tb sec square of ftb into sine square of pi ftb. Okay, so this is Sx of f, power spectra for Manchester format. Next, let us do power spectra for quaternary format. So in quaternary format, you are having a symbol duration. So t equal to 2 times of tb here. Okay, 2, it is extending for 2 binary bit duration. So t equal to 2 tb. V of f is tb, sink of 2 tb, sink of 2 f tb. Okay, and then RA of n is 5a square when n is equal to 0 and 0 n is not equal to 0. Okay, so now writing the general equation for the power spectra, Sx of f is nothing but V of f modulus the whole square by t summation n equal to minus infinity plus infinity RA of n e power minus j 2 pi n f t. So here again n is equal to 0 alone you have value. In the denominator you will apply 2 tb. So Sx of f is now nothing but modulus of V of f the whole square, which gives you 4 tb square sec square of 2 f tb in the numerator and 4 tb square in the denominator, because 2 tb, if you multiple 2 tb you will get 4 tb the whole square in the denominator. This entire thing multiplied by n equal to 0 alone you have value, which is 5a square. So you get 4, sorry, in the denominator you will have only 2 tb, right? It's not square, right? So 2 tb only. So you will get, you cancel this tb with this tb square and this 2, this becomes 2. So Sx of f is nothing but 10a square tb sec square of 2f tb. This is for quaternary format. Okay, next let us do power spectra for bipolar format. Power spectra for bipolar format. So here for bipolar format again we are having t equal to tb. V of f is tb sec of ftb only. RA of n, here only we are having 3 values, that is a square by 2 when n is equal to 0, minus a square by 4 when n is equal to plus or minus of 1, and 0 otherwise. So general formula Sx of f is nothing but V of f modulus the whole square by t summation n equal to minus infinity plus infinity RA of n e power minus j 2 pi n f t. Okay, substitute t equal to tb. V of f is this factor, you can substitute. When coming to RA of n, you have to substitute for n equal to 0 for n equal to 0, RA of n is a square by 2, n is equal to plus 1 and also minus 1. So carefully you have to do this expression. So Sx of f is nothing but V of f tb square, sinc square of ftb in the numerator. In the denominator you have tb only, and within bracket you are going to do 3 summation. First summation you put n equal to 0. So if you put n equal to 0, e power 0 is 1. So RA of 0 is a square by 2. Next you put n equal to minus 1. When you put n equal to minus 1, here e power, this becomes e power plus j 2 pi f tb because t equal to tb, and RA of minus 1 is minus a square by 4. So you write minus a square by 4 into e power plus j 2 pi f tb. Okay, and now you put n equal to plus 1. If you put n equal to plus 1, this factor becomes e power minus j 2 pi f tb, and here again minus a square by 4. So minus a square by 4 e power minus j 2 pi f tb. So now what you can do is, here you are having a square by 4 is common, and so you can just minimize this one. So here this becomes sinc square of ftb. Okay, you have a square by 2 minus a square by 4 times of e power plus j 2 pi ftb plus e power minus j 2 pi ftb. So this factor you can write e power plus j 2 pi ftb plus e power minus j 2 pi ftb divided by 2. You can make it as 2 here and 2 here. This factor you can write as a cos of 2 pi ftb. So here you are having a square by 2 and a square by 2 as a common. So this can be written as Sx of f equal to tb sinc square of ftb times of a square by 2 minus a square by 2 cos of 2 pi ftb. You have like this. You can take a square by 2 as a common. So Sx of f is nothing but a square tb sinc square of ftb divided by 2 into 1 minus cos 2 pi ftb. You know 1 minus cos 2 theta can be written as 2 sine square theta. So accordingly you can minimize this one. So this can be written as this factor tb sinc square of ftb by 2. This you can write it as 2 sine square 2 pi ftb sine square pi ftb. This 2 and this 2 will get cancelled out. So finally Sx of f is nothing but a square tb sinc square of ftb and sine square of pi ftb over. This is the final answer for bipolar format. Okay, so what we have done, just we know RA of n is taking 3 factor. One is at n equal to 0, n is equal to plus 1, and also n is equal to minus 1. We know V of f is tb sinc of ftb, so we are substituting for V of f in the numerator and t equal to tb in the denominator. Here when we are doing for the summation, in the summation we are having 3 values for n. One is n equal to 0, plus 1 and minus 1. So carefully you are substituting and reorganizing this equation, so that this factor we can write it as cos theta, so cos of 2 pi ftb. So and then you are after that you find a square by 2 is common, you are taking it outside, and this factor becomes 1 minus cos 2 pi ftb. So 1 minus cos 2 theta can be written as sine 2 sine square theta. So accordingly I am writing it as 2 sine square theta is pi ftb. Okay, so this 2 and this 2 will get cancelled out, so you are left out finally with this answer. This is for the bipolar formatting. Okay, and next finally power spectra for unipolar formatting. Here we are having for all the values for unipolar formatting. Okay, so here for unipolar formatting, T is equal to TB. V of F is nothing but TB sinc of FTB, and RA of n is nothing but a square by 2 when n is equal to 0, a square by 4 when n is not equal to 0. This we have derived already. So here only you are having all combination of n, that is from minus infinity to plus infinity. All combination of n gives you some value, and at n equal to 0 also you are having a square by 2. So all combination from minus infinity to plus infinity, you have all the combination. So you have to substitute. So general formula Sx of f is nothing but v of f modulus the whole square by t summation n equal to minus infinity plus infinity RA of n e power minus j 2 pi n f d. Now you carefully you substitute. So Sx of f becomes db for all the other summation n is not to 0 alone. Okay, you get a square by 4 e power minus j 2 pi n f db. You have like this. Now we need to rearrange and reorganize this equation so that we can have a nice plotting. So first of all, let us what we try to do is let us try to write these two combination as a single combination, or we will try to write this one in terms of sync function. Okay, so first we find here we are having this factor when n is not equal to 0. So what we will do is we will add n equal to 0. See, if you put n equal to 0 in this format, what you will get? You will get e power 0 a square by 4. So what you can do is the next step, you can add a square by 4 and also subtract a square by 4. Okay, so you add and subtract a square by 4 here. Therefore, what you will get, I'll write it here, s of f. This factor, let us take it outside. Okay, this factor, let us take it outside. So a square tb sink square of ftb by 2 and next I told you add and subtract a square by 4. So that you are introducing n is not equal to 0 also in this factor. Therefore, here you will get plus of, you multiply this here, tb sink square ftb into summation of n equal to minus infinity plus infinity a square divided by 4, n is not equal to 0, right? E power minus j 2 pi n f db 2 pi n f db, and you have to subtract one more n, right? So what I can do here, okay, I will, let me continue just okay, let me continue in the next slide. So what we are trying to do now is, here we are missing n is not equal to 0. If you introduce n equal to 0, what is the factor you will get? You will get a square by 4. So what you are going to do is you are going to add a square by 4 and subtract a square by 4. So when you are adding a square by 4, that will be combined. So here you can subtract a square by 4. So a square by 2 minus a square by 4, you can just combine together. Okay, so that is what I'm going to perform. So instead of this step, I will write it in the new slide. So now, from the continuation of the previous slide, what you are having is Sx of f is nothing but better, it is better, we will continue from this part. We are having tb sink square of ftb times of a square by 2 plus summation n equal to minus infinity plus infinity a square by 4 e power minus j 2 pi n f db, and here n is not equal to 0. I have just continued the previous equation. Okay, so now what you do is you add and subtract a square by 2. So this equation db sink square of f db, what this a square by 2 remain as it is, add a square by 4 and subtract a square by 4, or first you subtract a square by 4, add a square by 4 plus this entire thing, this segment n is equal to minus infinity, n equal to 0, a square by 4 e power minus a 2 pi n f db. So now what you can do is you can combine these two things and you can say that n is equal to 0 also introduced. So this Sx of f now becomes Tb sink square of f Tb, and similarly if you subtract these two things you get a square by 4 plus summation n equal to minus infinity to plus infinity a square by 4 e power minus j 2 by n f Tb. Okay, so now what you can do, you can just multiple this factor inside separately and write it as a two different part. So Sx of f is nothing but a square Tb by 4 sink square of f Tb, which is the first part, a square by 4 Tb sink square of, which is the first part. I have written it here. Second part is this Tb sink square of ftb will go here and the summation will come. So that is the second part, plus Tb sink square of ftb summation. We can also take a square by 4 outside, summation n equal to minus infinity plus infinity e power minus j 2 pi n f db. Okay, so this part, second part, a square by 4, I have taken it outside, which is a constant, not depending on n. I can take it outside here and multiple with this one. So I got two part, first part and second part. Okay. So once you are completing this part, we are okay with the first part because it is taking some form of the sink. We are also okay with this part, but this part you can see it's in summation e power minus j. So we will try to write express this in different format. So we are going to use the Poisson's formula. Okay, so according to the Poisson's formula, this expression generally can be written as summation n equal to minus infinity plus infinity e power minus j 2 pi n f Tb is there. No, this can be written as 1 by Tb summation n equal to minus infinity plus infinity delta of f minus n by Tb. We can write like this so that it is easy for us to minimize this one further. Okay, so therefore this equation now becomes Sx of f equal to a square Tb by 4 sink square of ftb plus a square Tb by 4 sink square of ftb times of, now you write everything in terms of 1 by Tb, not this one, this complete factor we are writing in this form. So this becomes 1 by Tb summation n equal to minus infinity plus infinity delta of n minus f minus n by Tb. This Tb and this Tb will get cancelled out, and now you can understand sink function is multiplied by periodical impulses. This impulses is placed at f del of f, that is f equal to 0, f equal to f minus 1 by Tb, f minus 2 by Tb, like that. So this is a periodical impulses multiplied with the sink function. Okay, so when you draw the sink function, that is this sink function, sink square of f by Tb, you will have a function like this, sink square of f Tb, you will have a sink function like this. So when you normalize at 0, you have some value, but at 1 by Tb, 2 by Tb, minus 1 by Tb, minus 2 by Tb, like that for all the values of Tb, 1 by Tb, you have 0 only. Okay, so only at f equal to 0, this is the sink function. Only at f equal to 0 or t equal to 0, you have some value. Not f, t equal to 0, you have some value. of 1, but when you are talking about t equal to 1 by tb, 2 by tb, everything, you are having a sinc function is 0. So but your delta function f minus, sorry, t minus f minus by tb, you have this, you are having a function like this. So periodical impulses 1 by tb, this is f, not the spectrum we are drawing, okay, minus 1 by tb, like this, periodical impulses like this till infinity. So what will happen is, when this is multiple only at this point at 0, if equal to 0 alone, you will have the multiplication value. In all the other points, you will have only 0 value. So this particular equation can be further simplified. So only at f equal to 0, you have some value, and all the other value you are not having value. So this can be further simplified. So you can directly write, so when n equal to 0 alone, we have non-zero factor. Okay, we can write non-zero factor for multiplying sinc and periodic impulse. So only at one point, all the other points you are having 0. So accordingly, you can minimize this equation. You can put only at f equal to 0 and n equal to 0, you get only delta of f, and all the this sinc square of f tb will become 1. During that point at f equal to 0, sinc square of f of tb becomes 1. So having that factor, you can write sx of f is nothing but, first part is a square tb sinc square of ftb by 4, and second part, as I have told you, sinc function will be nulled out at a plus or minus of 1 tb to plus or minus of 2 by tb, like that. So we can write the second function directly as a square divided by 4 into del of f. Okay, so this will be your final answer for the power spectrum, okay, for unipolar format. So now let us try to compare. This is for unipolar format. Unipolar format. For polar format, so let us now try to write all the power spectra and have a basic understanding how the power spectra looks like. For polar format, Sx of f is nothing but a square tb sinc square of ftb. This is for polar format. Manchester format, Sx of f is nothing but a square tb sinc square of ftb by 2 into sinc square of pi ftb by 2. This is Manchester format. And quaternary format, 10a square tb sinc square of 2ftb. This is for quaternary format. And Sx of f equal to a square tb sinc square of ftb sine square of pi ftb. This is for bipolar format. Over. So 5 formatting, we have completed the power spectra and I have summarized here. So from this, what do you really understand? You see the first formatting. In the first formatting alone, you are having a delta function. In all the other formatting, you are having only sine function or sinc function. Only in the first formatting, you are having a delta function. Delta function is because of the presence of the DC component. See, when we are deriving all these equations, we have assumed equally likely symbol. That is, probability of generating 1 is equal to probability of generating 0. So we have assumed equally likely symbol. So you can see there is no presence of DC component in polar, Manchester, quaternary or bipolar as we discussed in the class. Only for unipolar formatting, delta function is present. So which is nothing but the presence of DC component. That is the first point you need to understand. Second point you need to understand is compare the amplitude of all the formatting. See the amplitude of the unipolar formatting A square TB by 4. Okay. Amplitude of polar formatting square TB. For Manchester formatting A square TB. For bipolar formatting is also A square TB. But for quaternary formatting 10 A square TB. Okay, so when you are comparing the amplitude tells you what is the power consumed. So power consumed out of all the 5, unipolar occupies the lowest power, A square TB by 4. That is only 1 by 4th of the power consumed by the unipolar format. Whereas polar format, Manchester format and bipolar format consuming A square TB times. The power consumed is A square TB times. You see the quaternary format, it is 10 A square TB. So it is having 10 times of the power consumed by polar formatting or Manchester formatting, or 40 times of the power consumed by unipolar formatting. That is what you have to understand. So you just compare the magnitude part or amplitude part. From the amplitude part you can understand the unipolar formatting is consuming the lowest power, whereas the quaternary formatting is consuming the largest power, and polar and Manchester and bipolar consumes the same power. Okay, that is the second point you need to understand. Third point is coming to the bandwidth. So bandwidth, when we are talking about the bandwidth, you see the factor which is inside the sinc function. Okay, sinc function or sine function. So here in unipolar formatting, you are having f times of TB. Polar formatting also you are having f times of TB. Bipolar formatting also you are having f times of TB. So f times of TB in the sense it occupies a normal bandwidth. Okay, so these all the 3 occupies the same bandwidth and the normal bandwidth. And you see Manchester formatting, you are having f times of TB by 2. TB by 2 in the sense time period is reduced by 2. So frequency bandwidth will be increased by 2. So Manchester formatting occupies twice the bandwidth compared to the bandwidth occupied by the unipolar, polar or bipolar formatting. Okay. So Manchester occupies twice the bandwidth. And for quaternary format, you see here you are having f times of 2 TB. So f times of 2 TB in the sense time is increasing, so bandwidth is reduced by 2. So quaternary format, even though it is consuming the maximum power, it is consuming the very lowest bandwidth. Okay, so you are comparing the power, bandwidth, power and presence of DC component. So please, I will tell you again, there is DC component present only in unipolar format, provided when you are taking equally likely signal, which is proved from this derivation. Okay, so this is the presence of DC component. That is point number 1. Point number 2 is that your amplitude, that is how much power is being consumed, which is consuming largest power. So the power consumed by the unipolar format is very minimal, which is A square TB by 4. Whereas for polar formatting, Manchester formatting and bipolar formatting, the power consumed is A square TB. You see the magnitude part, amplitude part, A square TB. Here again A square TB. Whereas power consumed by the quaternary format is the maximum, which is 10 A square TB. That is the third point you need to understand. Fourth point is bandwidth. When we are talking on the bandwidth, you can see from this derivation, unipolar formatting, polar formatting and bipolar formatting occupies the same bandwidth of f, that is frequency f. Okay, whereas Manchester formatting is occupying twice the bandwidth. Why do I say twice the bandwidth? Because the bit duration here within the sinc function, bit duration is divided by 2. So the bandwidth will be higher. That is twice the bandwidth. Okay, so this is twice the bandwidth, Manchester. Whereas quaternary formatting is occupying half of the bandwidth of the other formatting. So these are the points that you need to understand. So with this, I will stop for the today's video. Okay, so thank you.